So I've got you for about 30 minutes, and here's my agenda. We're going to introduce the company briefly. We're going to talk about handheld scanning. We're going to do a live demo. And then we'll dig into the NSRP panel project, ShipScan. And I'm going to finish with a brief discussion about where we think the technology is headed. I've got some new stuff to show you. So a little bit about us. I work out of our Boston office. Don't have a Boston accent. There's a residue of a Canadian accent in there if you listen carefully. And we make our scanners in Houston and do the software development in Germany, Frankfurt, Germany. So from left to right, Raphael Spring is our Chief Technology Officer, and he's an ex-Google guy. He worked on the Google Glass project, Google Goggles, Google Tango. So the short form is that he's an expert in computer vision, and his specialty is doing computer vision on phones and tablets, on mobile devices. Brian was ex-Trimble. Some of you may have used the product in the past called LaserJam. It could take 1 billion points back in the early 2000s into a CAD tool, a lighting tool. Trimble bought that in 2006, and that's where Brian was. A long time ago, I was a Schlumberger engineer, so I have a background in oil and gas. And more recently, my wife and I started a conference business called SPAR, which is all about 3D laser scanning and continues to this day. We sold the business to the current owners in 2010. I've been around point clouds for 18 years. So, we're a little company. You know, we're 10 people. And we try to be Switzerland with our data. So all of these companies, whose logos are represented here, have at least one product that can read our binary file format. So we've reached out to the industry and said, how can we make our data interoperable with your data? And so we've got a pretty good list. We're very proud to have SSI and Autodesk on this list. These are some of our customers. We won't find the slide on our website. You know, don't worry about becoming one of our customers. Occasionally I show this at a marina event. But one of our earliest customers was Bath Iron Works up in Maine. In fact, the lead scanner there does a lot of ship check work. Bath has a bunch of these devices. He's coming back from Japan today, and he's been there all week doing ship check on some ships for the Navy there. We never see that data. So what is handheld scanning? So this is our scanner. I've got it plugged into the projector. I'm going to put this data up in a minute, but normally it operates untethered. And let me just talk a little bit about how it works. There's an infrared camera and an infrared projector. So it's projecting a pattern of dots, and the camera sees those dots. So we humans can't see in the infrared, so we don't see them. But there's a known baseline between the projector and the receiver, and the projected pattern we see with the camera. It's a pinhole camera model. Let me wave my hands a little bit. We get two angles and a baseline distance. We calculate the distance to each dot in the sequence. So I'm going to show you some of those dots. Last week I was in Fort Leonard Wood, Missouri, and at an Army base, military police expo. It's one of our use cases, is mapping crime scenes. And there was a booth there with some infrared glasses, or infrared scopes. And so I put the scope I turned the camera on, put the scope on the scene, film this with a phone. So you can see these little dots.
So Tom, what am I looking at here?
You're looking at the projected pattern from our infrared depth camera. So the way it
So you
works,
can see those dots. That's what we're trying to do. That's what's making this 3D.
What product is it?
This is the DotProduct DPI-8X.
Is that available from?
DotProduct.
So we're taking an RGB signal and a depth signal, marrying it together, stitching it in real time, and we produce a color polygon. That's about as deep as we're going to go today into this. There are some constraints. This is primarily an indoor. It operates in the infrared. Half of the energy from sunlight is in the infrared. So we can work outdoors, or late in the afternoon, or at night, when the sun is low or on the horizon or is not there at all. Okay, that's a constraint. We're not going to scan a 150-foot long hull or a 300-foot long hull with this device. We're about small spaces. So, 10 by 20, 20 by 20, we eat that up. We do that all day long. But no, not whole ships. This is for compartments, engine rooms, and another thing, the more congested the geometry, the more congested the scene, the happier we are. Okay? It works, it uses the geometry of the scene to track, so the more geometry, the better. A big scene for us is about 50 million points, and a 50 million point file is about 50 megabytes. Typically, we ship around files that are 10, 20 megabytes. You can email the files. That's one of the advantages of this technology is we can get it from the site, back to the office, over a Wi-Fi lane, a cell network. It's fast. Accuracy, we're 1/8-inch kind of tool. Okay, it's a longer discussion about accuracy with structured light devices. Happy to have that with you, but I want to leave you with that. We're not a metrology tool. We get the kind of accuracy you get a skilled operator with a tape and a plumb bob can get. Maybe, they climb 16th, but we're in that range. And we like to be 3 to 6 feet away from whatever we're looking at. The range, maximum range is up around 15 feet. We'll put these devices on poles to reach, like selfie sticks, to reach farther away. Anyway, I wanted to just put this all on the table. If you can live with these constraints, we have something that I think works very well. So we got involved in the marine side of things. Prototype number 1. And if you look very closely, you'll see some duct tape in there. It was literally duct taped together. And a guy by the name of Mark Kluza, who now works for Autodesk, came by my house. I took him down into my basement. And I had this very long boat building project underway. I won't tell you how many years it took me to finish this. So we scanned the boat. And I'm very happy to say that later I modeled this boat in Rhino and overlaid the scan. I'm happy to show you that, but that's another story. The boat floats. It's sweet sailing too. So. Okay, back to some serious stuff. NSRP's ShipScan panel project. So we ran into Pat Roberts at a trade show. One thing led to another, and we're partnered with Ship Architects, SSI, Oslo, Bollinger, to document workflows for handheld scanning. And we came up with these use cases, validating the geometry dimensions of fabricated items, creating as-builts where you may have old, out-of-date 2D information or old models that don't exist or out of date. Another use case that seemed pretty obvious to us was compartment checkout. So we've done some field work at Oslo, Bollinger, Conrad, I learned recently what a pokey boat was, and we got protein and got some data too. So I am going to show you some of this data in just a minute. So the precursor to this work, the thing that led us to think that this might be a good idea, the ShipScan project, Josh Tribby from Ship Architects and I went to FMT, Florida Marine Transportation, just outside of New Orleans, a little over a year ago. And FMT was building 5 of these push boats. There's the shipyard. And so we went on site, we're scanning. I'm setting up some targets in the scene, not because we need them, but we can use them. So if you're using targeting, total station, survey control as part of your workflow, we can integrate that with our data. We can constrain our data with those very accurate measurements. It's optional, but it's a very good workflow. here's some other shots, and you don't see it in these photos, but it was hot, especially for a guy from Boston, and water was dripping on our heads, and yeah, it put our equipment through its paces. And here's some of the data that we captured. I just made a little video. The object was to capture the grading. They're going to make 5 of these boats, and they wanted to update the CAD models with this geometry. So the interesting thing about this project was that 3.5 weeks before Josh and I showed up, measuring this the traditional way. The tape measures, sketch pads, I don't know if they had plumb bobs, but we had the opportunity to measure the same space with a handheld scanner and by hand. And we did a one-for-one comparison. How many square feet per hour? I'll tell you, this is a very conservative, because I was doing some things that normally I might do if I were just in a hurry to get the data. So we stretched the time. But even with that, there was a 70% improvement on the data collection time. Okay, so it's faster to use a handheld scanner than to do it by hand. This is a data point that we have, a one-for-one comparison. We don't always get to do those one-for-one comparisons, but we had one here. So this really encouraged us. The other thing is that the data that we output from these devices is digital. The output from numbers that need to be entered into a computer, that all takes time. We're starting with digital data. So we think there are other improvements to be had downstream of the data capture. All right, so with that, bear with me. There's always the chance something could go terribly wrong. I'm going to connect the HDMI cable for the projector to my scanner. And now the moment of truth, I'll press the mirror mode button. There it is. Okay. So I'm going to do a scan. I want to show you just how fast it really is. So I'll reset for a new scan. And I'm going to start. Dad, would you join me? I always like to get a human in the scene too. All right, just hold still there. So what we're doing is, it's okay, I'll tell you that. So we're turning the scene green and yellow. And when we capture the data, it turns green or yellow. The greener, the better. Okay? So we know in real time. So I'm going to turn Dad into a Martian. He's green right now, but we'll bring him back in just a second. I'm going to go get this bulkhead over here. We've got this tank right here, and I'll make sure I get the tank down here. All right, finished. We're good, Pat. Thanks. Making a backup copy of the data, and there we have it. Okay? So every pixel in here is an XYZ coordinate. So let me show you. I'm going to run an optimization routine. All the processing is done on only feeding the projector. It's not, there's no computation being done other than display what I see here. This is valuable in internet tonight. Do that. I'm going to set up a coordinate system. We're going to move the point of origin down to the deck. I'm going to set Z perpendicular to the deck. I'll make X come out of this bulkhead. Okay? Taking some liberties with the seam. And then we're going to take a measurement. So I'm going to pick a point on top of this table, another point on the deck, and we'll go to inches. So it's telling me that we're 40.8 inches from here to the deck, straight down. Okay? So it's that fast. We can capture a small area really quickly with a light format and bring this into a CAD tool. So let me show you some of the data that we captured at some of the shipyards we've been working in this summer. So I'm going to go back to laptop. So this is I'm told, a companionway house. We're at Conrad here with us. And Lee Jerry took some instruction from me about 5 minutes. And then he took the scanner from my hands. We walked inside this structure. It's about 12 feet long, something like that. I can't remember exactly. 10 by 12. We can measure it in a second. And he captured the data. So we're just walking around. This data you see up here is the data that we saw through the doorway. There's a little backpack right in here. We're going to come back to that in a minute. Okay. So next, what we want to do is compare this to the CAD model. We actually had a ShipConstructor model of this structure. So I'm going to pull that down, and we can do this on the tablet too. We don't have to do it on the laptop. Just bear with me. This is some early software, and I've got to do some clicks here to get to the right place. Here we are. Okay. Now I'm going to line these data sets up, the CAD with the point cloud. So there's the CAD model. That's the ShipConstructor model. Okay? And it's a light representation of it. It's a mesh. And right now, so the way we do that, we have this very simple to use registration tool. We pick a plane in the CAD, in the point cloud. That's step one. Step two, we're going to pick another plane in the point cloud and the corresponding plane in the CAD. That's step two. And then step three, you can probably guess, I'm going to line up the deck with the deck. Now it's going to go and have a think. Wait for it. There they are. They're lined up. So you don't need to be a surveyor to do this alignment. And then the software takes over. It's doing a course alignment and then our software in a step that's, done automatically. And we can look at just the point cloud, or we can look at just the CAD, and there we have the blended view. Okay? And then we're going to calculate a deviation. We're going to show the difference here between the CAD and the point cloud. Okay, so like you said, we're still fooling with the interface here, but remember that backpack? That backpack was not in the CAD model. And there it is, it stands out, it's red, bright red. So think compartment checkout, do I have stuff in the compartment that is not in the model, and vice versa? This is the way to go, I can't get that right away. There's a piece of steel lining up, leaning up against the wall here. We see that immediately, it's red, it stands out. And this data that is in the point cloud and not in the CAD model, because it's outside the CAD model, just turns red right away. We could spend more time talking about this, but we don't have that time today. So there's an example of how we can use this data to compare reality with modeling quickly and inexpensively. Let me show you some other data. This is, you've probably been hearing about the CAR-W project. This is one of the plates for the CAR-W project, robotic welding. And so we've captured it. We haven't done the work to compare it with the model, but we will. But we get very nice data. There was a shaft of sunlight coming through the roof of the building. That explains this hole in the data right here. I'll show you a couple of others. This was a study to look at some frame alignments. This is a panel down here, there's another panel up here, and I want to see how the frames lined up. So that's some analysis work to be done. Show you one others. I'm going to go to, this is a bogey boat. There was no model for this boat. This is the pilot house. So this speaks to the use case of where we need a model. We need to model, so we're going to make some renovations to this. Some renovations, probably wrong, repairs, modifications. So now we can bring this data into our CAD tool and either use this as the backdrop for design or model some of these elements.
Is this one scan or merged scan?
This is to scale. So in this scene, you can't see it right here, but there's a scale bar that we used to dial this in. There's a 4-meter scale. We don't need that scale bar, but we want it would be the very best data that we can deliver.
Is it single scan or?
Oh, sorry. Yes, it's in one scan. Yeah. Yeah. This gives you an idea of, this is a rather large scan for us. Okay. And we walked around. We wanted to get all right. I'm going to come back to this one more time. I want to show you, though, I've got the data in AutoCAD. This was remember the companionway structure? So we can export our file on our laptop in recap format. Okay, so we don't need to open recap. We can just say file save as recap. This is a very recent capability for us. We got the SDK from Autodesk about 3 weeks ago, and 2 days we had it. So if you're using recap as part of your workflow, great. But if you don't want to be bothered opening recap, you can use our data by saving it as a recap file and attaching it to an AutoCAD file. And that's what we have here. We have the CAD model and the point cloud in the same coordinate system. This is in the ship coordinate system. So we can use the CAD tool to investigate deviations. All right, let me go back to PowerPoint for just a second. Now I'm running just about the limit of our time here. This is a This is an autonomous vessel designed in Boston by Sea Machines. It started out life as a workboat, riverboat. That's twin Z drives. So Sea Machines modeled this in Rhino. This is the scan data, and we have a good workflow for bringing the data into Rhino so that you can use the data in Rhino. Here's a rendering, and this radar arch you can see here was fabricated, was designed in Rhino, matched up with the point cloud, so we knew it was going to fit. They fabricated it and then it bolted right up. So here's a use case when we have no CAD, we scan it, we fabricate some modification and show it. All right, so I'm going to finish with just a little discussion about where we're going to go with the technology. Let me go back here, and I'm going to pull up a model that I captured at about 5 this morning, and I captured it with this device. This is an Intel RealSense sensor. You can buy this today. It costs $100. And I want to show you something that I think is very cool about this technology. We have the ability to take high-resolution photos with it. So there's a photo. So imagine you're walking down space. You're going to take 200 photos. Let me show you some. Okay, go back. There's the brochure. You know, you can read the font. There's the fire suppression system. So if I hand you those photos and make you a sketch, the modeler is get that mob in your head. That's not so easy. That's hard. It's hard for most of us. So what we have here is we know where every camera shot is taken. See those little blue camera icons? Okay? And if I click on the photo, it takes me to the place in the point cloud where that was taken. Okay? So I can navigate the photos. I know where every photo is. And I can go and take a measurement. So this is rough, this is early, this is crude. It's done on a $150 camera in our software. But I think what we have here is, I'm hoping what we have here is the makings of a walkout tool to go and capture a space. Use some of the same methods that are working for you today, you know, taking photos. But let's augment this with some tools to give the designers back at the office that experience of being there and not just having to interpret the photos. Okay? Anyway, that's just a little peek. There are more sensors backed up on the runway. The data's going to get better. This will operate on your phone. So I think this approach has we believe it has a bright future.